All right, guys. So today we're going to talk about the vertex form of a quadratic equation. The vertex form is y equals a times x minus h to the power of 2 plus k. hk is the vertex and x equals h is the axis of symmetry. Okay, so it says give the axis of symmetry and vertex of each equation. Well, they already gave us the format in vertex form, so all we have to do is pick out what our vertex is first. Okay, so our vertexes are h and our k, but it's always the opposite sign of the number that's in the parentheses here. So our vertex here is going to be -4, -2. Then our axis of symmetry is always the x value of the vertex, so x equals -4. Okay, on number 2, our h is going to be +3 because it's the opposite of this. Our k, there's not a number there, so it's going to be 0. So our vertex is 3, 0. Our axis of symmetry is the x value of the vertex, so x equals 3. Number 3, our vertex, opposite of this number, so 5, -4. Axis of symmetry, x equals 5. On number 4, okay, this time they did not, it is still in vertex form, but they don't have anything in the parentheses here. So since they don't show a number in parentheses, our x value is actually going to be 0, because this is like saying -2 times x plus 0 squared plus 3. Okay, so all they did is condense this down, because if you do 0 squared, that doesn't change anything. So it's just like saying x squared. Okay, so our vertex here is going to be 0, 3, and our axis of symmetry is x equals 0. Okay, so the graphing part, so it says graph each equation using a table of values, identify the axis of symmetry, vertex, domain, and range. Okay, you can actually do this the same way that we did on the last note sheet. You can go and type this in on your y equals to fill in your table and your graph. But our vertex and axis of symmetry, we should be able, actually all this information right here, we should be able to fill in just by looking at this. So our vertex is the opposite of that, so it's -2, 7. Our axis of symmetry is x equals -2. Domain is always all real numbers because it's a quadratic graph. Our range, because this is a negative, that means the graph is going to open downward. So you say y is less than or equal to, and it's always the y value of the vertex, which is 7. Okay, so to fill in your table and your graph, you can do that on your calculator, or you can do it by hand, either way. Okay, our table is -4, 3, -3, 6, -2, 7, -1, 6, and 0, 3. And then we want to fill in our graph. So -4, 3, -3, 6, -2, 7, -1, 6, and 0, 3. So it's going to look like this. Okay, on number 6 here, so our vertex is going to be 1, 0. Okay, because it's the opposite of this number, there's not a number out here, so it's 0. Axis of symmetry is x equals 1. Our domain is always all real numbers. This is going to be a open upward because this is a positive number, so it's going to open like this. So we say y is greater than or equal to, and then it's the y value of our vertex, which is 0. To fill in the table and the graph, like I said, you can either do it by hand or you can do it on your calculator. So I have -1, 12, 0, 3, 1, 0, 2, 3, and 3, 12. Okay, -1, 12, and 3, 12, you're not going to be able to graph on there, so just do your best here. So we have 0, 3, we have 1, 0, and 2, 3. Okay, the rest are going to be up here off of the graph, so it's just going to look something like this. Okay, all right, now flip over to the other side. So transformations from the parent function. Okay, so the most simplistic quadratic equation is y equals x squared. This is known as the parent function. A transformation is a change to the size or position of a figure. Okay, they want us to graph each function, describe how it compares to the parent function shown on the graph. Okay, so they already have the parent function graphed on here for us. They want us to fill in our table and graph our points here. Okay, so if you type this in on your y equals and go to your table, our table is going to be -4, 4, -3, 1, -2, 0, -1, 1, and 0, 4. So we can graph those points. So we have 1, 2, 3, 4, 1, 2, 3, 4, 3, 1, 2, 0, -1, 1, and 0, 4. So our new graph is going to look like this. Okay, well, what did it do from the parent function to the new function? It moved to the left 2 units. So over here on transformation, you just say left 2. Okay, then we do the same thing on number 8. They already have the parent function here for us. We just need to fill in our table and graph this new one. Okay, so our table is going to be -2, 9, -1, 6, 0, 5, 1, 6, and 2, 9. Okay, so -2, 9 to 1, 2, 3, 4, 5, 6, 7, 8, 9. That's actually going to be up here. -1, 6, 1, 2, 3, 4, 5, 6, 0, 5, 1, 6, and 2, 9 is going to be up there. Okay, so from the parent function here, here's the parent function, it shifted upward 1, 2, 3, 4, 5. So it went up 5. Okay, number 9, same thing. So they have the parent function. We want to fill in the table for this one. So we have -3, -2, -2, -5, -1, -6, 0, -5, 1, -2. Okay, so then from there we want to graph this. So -3, -2, -2, -5, 1, 2, 3, 4, 5, -1, -6, 0, -5, and 1, -2. Okay, so it's going to look something like that. So this time our vertex, it shifted left 1 and it went down 6. 1, 2, 3, 4, 5, 6. So you say left 1 and down 6. Okay, and then on this last one here, so fill in our table. So we have 2, -3, 3, 0, 4, 1, 5, 0, and 6, -3. So 2, -3, 3, 0, 4, 1, 5, 0, and 6, -3. Okay, so on this one, notice how it flipped over. That's because of this negative right here. So you just say flipped. Okay, it also shifted to the right 1, 2, 3, 4. So right 4, and it went up 1. Okay, all right, so let's look at this next page. It's still in the same note sheet. Okay, fill in your table. We have -2, 5, -1, -4, 0, -7, 1, -4, and 2, 5. So we have -2, 1, 2, 3, 4, 5, we have -1, -4, 1, 2, 3, 4, 0, -7, 1, 2, 3, 4, 5, 6, 7, 1, -4, and 2, 5. Okay, so notice that this time our graph here is stretched down and it's more narrow than what this was. So you can say stretched / narrow. Okay, it also shifted down 7 units. So you can say down 7. Okay, on the next one, fill your table in. So we have 1, -4, 2, -2.5, 3 is -2, 4 is -2.5, and 5 is -4. So we have 1, 2, 3, 4. We have 2, -2.5, 3, -2, 4 is -2.5, and 5 is -4. So it's going to look something like this. Okay, and notice on this one, it's wider, which is also called a compression. So you can say compressed, which it means wider. Okay, it also shifted to the right 3 units. And it shifted down 2. Okay, so let's put it all together. So how we can look at an equation and automatically know what the transformations are going to be. So given this quadratic equation in vertex form right here, if the h right here, that is your horizontal shift. So it tells you how you're moving left and right. If your h here is a positive, then it's shifting to the left. If it's a negative, it's shifting to the right. Your k is the vertical shift, so it's up and down. If it's a positive, it shifts up. If it's a negative, it shifts down. If your a is a negative, the function is reflected across the x-axis, so it's just going to flip it over. If your a is greater than 1, it represents a vertical stretch. If your a is between 0 and 1, it represents a vertical compression. Okay, so writing equations based off of transformation. So it says transformations for the parent function y = x² are described below. Write an equation to represent the function. So it says it's translated 2 units right. Okay, well, right means that our h is a negative, and if it was 2 units, then that means that we have y equals, they didn't tell us anything about the a, so you ignore that. You just say x, right's negative, so x minus 2 squared. And they didn't tell us anything about a k, so you ignore that part. Okay, the next one, it says translated 5 units up. Well, up, that's your k, and up is a positive k. Okay, it doesn't say anything about the h, so that means it's just going to be an x squared there, and it just says up 5 units, so you say plus 5. Okay, the next one says translated 3 units to the left, so the h is a positive, so x plus 3, and 4 units down, so the k is a negative, so you say minus 4. Translated 7 units right, so it's a negative, so x minus 7, and 4 units up, so plus 4. Reflected over the x-axis, that means our a is going to be a negative. Okay, so you just say y equals negative. It doesn't say anything about left or right, so actually, just ignore the parentheses right there. You can actually just say x squared because it doesn't say left or right, which just means it's 0. And then it says translated 3 units down, so minus 3. Reflected over the x-axis, so it's a negative again. Then translated 5 units right. Okay, so we have y equals a negative. If it's 5 units right, so it's a negative, so x minus 5. And 2 units down, so minus 2. Vertically compressed by a factor of 1/3. So that's our A is 1/3. So you say y equals 1/3. Okay, then it says translated 8 units up. It doesn't say anything about left or right. So you just say x squared, and 8 units up is plus 8. Vertically stretched by a factor of 2. So our A is 2. And it's also reflected over the x-axis. So it's also a negative. So y equals a -2. Then translated 4 units to the left. Well, left is a positive, so you say x plus 4 squared. And that's it. Okay, so that is talking about transformations from the parent function. So this is all vertex form of a quadratic equation.